Hello there, and welcome to The Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind, and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into a question that feels both simple and impossibly vast. Where is everything in the universe going? But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let us gently begin our journey into motion, into stillness, and into the quiet drift of everything that exists. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. Tonight we won't rush. We'll simply follow the movement, wherever it takes us. There's a quiet assumption you carry with you almost all the time. Right now, as you sit or lie there, listening, it feels as though you are perfectly still. Your body is resting. The room around you is calm. The air is quiet. Nothing seems to be moving in any meaningful way. And yet, that feeling is not quite true. In fact, at this very moment you are moving. Not just a little, but at speeds so great that if you could truly feel them, it might take your breath away. But you don't feel anything at all. And that is where our journey begins. Imagine sitting inside a train. It's late at night. The lights are dim, and the world outside is hidden in darkness. The train begins to move, slowly at first, then faster and faster until it is gliding smoothly along the tracks. Inside, everything feels still. Your cup of water doesn't slide across the table. Your body doesn't lean or strain. If you close your eyes, there is no clear sensation of motion. It feels as though you are at rest. But outside, the world is rushing past at tremendous speed. This is the strange and gentle trick of motion. When everything around you moves together, motion disappears into stillness, and something very similar is happening to you right now. The ground beneath you, the earth itself, is turning, slowly, steadily, almost imperceptibly. If you are somewhere near the middle of the planet, not too close to the poles, you're being carried around in a great circular motion, completing a full rotation once every day. If we were to describe it softly, without numbers, you could imagine it like this. You're being carried along the surface of a vast silent sphere, turning through space like a slow, patient wheel. There is no wind, no resistance, no sense of rushing forward, just a quiet, continuous motion. And because everything around you, the air, the buildings, the oceans, is moving with you, there is nothing to compare against. No reference, no signal that says you are moving, so it feels like nothing at all. But the Earth does not simply spin, it also travels. It moves around the sun in a wide, graceful path, tracing out a loop that takes an entire year to complete. And the speed of that motion is far greater than the gentle turning of the Earth. It is a deep, sweeping journey through space like a long, silent orbit around a distant fire. And still, you feel nothing. The same quiet trick applies. Everything near you is part of the same journey. The air, the planet, your own body, they all share the motion. So once again, there is no sensation, no internal signal to tell you that anything is happening. And yet, you are travelling, farther than any road could ever take you. But even this is not the end of the motion. The sun itself, along with all the planets, including Earth, is moving through the galaxy. It drifts in a vast orbit around the centre of the Milky Way, taking hundreds of millions of years to complete a single journey. If the Earth's motion is like a wheel turning, and its orbit around the Sun is like a slow dance, then the motion of the solar system through the galaxy is something else entirely. It is more like a long drifting voyage through a quiet ocean of stars. There is no edge, no destination in sight, just a steady forward glide through a vast and silent space. And still, you feel nothing. No wind, no vibration, no sense of speed, just stillness. But here is where things become even more interesting, because all of this motion, the spinning Earth, the orbiting planet, the drifting solar system, raises a deeper question. How do we know we're moving at all? If you were inside that train, with no windows, no sound, no sense of acceleration, you might reasonably believe that you were completely at rest. After all, there would be no evidence to suggest otherwise. In many ways, this is exactly our situation in the universe. We do not feel the Earth spin. We do not feel it orbit. We do not feel the sun's motion through the galaxy. All of it happens silently, invisibly, beyond the reach of our senses. So how can we be sure? The answer, as it slowly emerged over centuries of careful observation and quiet thought, is that motion is not something you can detect on its own. Motion only exists in comparison to something else. You can only say you are moving if you can point to something and say, relative to that, I am changing position. Without that reference, motion becomes ambiguous, almost meaningless. And this realization changed everything. It meant that the feeling of stillness you experience right now is not a sign that nothing is happening. It is simply a sign that you are moving along with everything around you, perfectly in sync, carried together through space like passengers on a train with no windows gliding through the night. And as we continue this journey, we will begin to uncover something even more surprising. Because not only are you moving, everything is moving. The Earth, the Sun, the galaxy, even the vast structures of the universe themselves, all drifting, all flowing, all heading somewhere, quietly, relentlessly. And the question that gently waits for us, just beyond this moment of stillness, is not whether we are moving, but where. Where is all of this motion leading? And is there, somewhere in the distance, a destination, or only an endless drift? If you stay with that feeling for just a moment longer, that quiet sense of stillness, something begins to shift. Because once you accept that you're already moving, even without feeling it, a new question slowly emerges. Not just are you moving, but how far have you already travelled? Let's take it gently, one layer at a time. Imagine a single day of your life. From morning to night, you wake up, move through your routine, and eventually return to rest again. It feels like a small journey, contained within familiar walls and familiar streets, maybe a few kilometers at most. But beneath that ordinary day, something much larger has quietly unfolded. As the Earth turns, you're carried along its surface in a wide circle. If you could trace your path through space, not just across the ground, but through the universe itself, you would see a long, curved line stretching far beyond anything visible from your window. Over the course of a single hour, that path would already span hundreds of kilometers. Over the course of a full day, it would extend into tens of thousands. And over the course of a lifetime, it becomes something almost impossible to picture. Not because the motion is violent or dramatic, but because it is so steady, so continuous, that it disappears into the background of your experience. Now let's widen the view just a little. The Earth does not simply spin in place. It moves around the Sun in a slow and steady orbit, completing one full journey every year. If the rotation of the Earth is like turning in place, then this motion is more like walking in a great circle, only the circle is so large that it would take light itself several minutes just to cross it. and the speed of this motion is far greater than the turning of the Earth. If we were to describe it softly, in a way that feels more like a story than a calculation, you're being carried through space at roughly 30 kilometers every second. Not every hour, not every minute, every second. But again, there is no sensation, no rush of wind, no feeling of acceleration, because just like before, everything around you is part of the same journey. The air, the oceans, the continents, even your own body, they all move together, locked into the same quiet orbit. There is nothing to push against, nothing to reveal the motion, and so it feels like nothing at all. But even this is only one layer of a much deeper motion, because the sun itself is not still. It drifts through the Milky Way galaxy, orbiting its center in a journey so vast that it takes about 230 million years to complete a single loop. That means the last time the sun was in the same position it occupies today, the Earth was home to dinosaurs, and during that long, slow orbit, the sun carries everything with it: the planets, the asteroids, the comets, and you. All of it moving together like a quiet caravan of worlds, circling through a galaxy filled with hundreds of billions of stars. If we soften the numbers again into something more imaginable, the sun travels through the galaxy at a speed of roughly 200 kilometers every second, which means that even as you sit quietly, doing nothing at all, you're being carried forward at a pace far beyond anything ever built by human hands. And yet, there is still more, because the motion of the sun is not a simple flat circle. It also rises and falls gently, moving above and below the thin disk of the galaxy, like a buoy drifting on a slow, invisible tide. Over millions of years it weaves up and down, tracing a soft, vertical rhythm through the stars. So your path through the universe is not a circle, or even a spiral, but something more complex, a flowing three-dimensional curve, like a ribbon drifting through water. And if you could see the full shape of your journey, from birth to this moment now, it would not look like a straight line, or even a simple loop. It would look like a long winding thread, stitched quietly into the fabric of the galaxy. And still, you feel none of it. No vibration, no motion sickness, no sense of speed, just stillness. But there is something even more subtle hidden within this motion, because when scientists first began to measure how fast the sun was moving around the galaxy, they noticed something strange. There wasn't enough visible matter, stars, gas, dust, to hold it in place. If the galaxy only contained what we could see, the sun should have drifted away long ago, escaping into the darkness between galaxies. But it hasn't. It remains bound, held in orbit, as though something unseen is anchoring it in place. And so, quietly, another idea emerged, that there must be something else there, something invisible, something that does not shine, does not reflect light, and does not interact with us in any direct way, but still has mass, still has gravity, still shapes the motion of everything around it. This is what we now call dark matter, not because it is truly dark in the way we think of darkness, but because it does not reveal itself to us through light. Instead, it reveals itself through motion, through the way galaxies spin, through the way stars move, through the way the sun continues its long, steady journey without drifting away. It is, in a quiet sense, the hidden scaffolding of the universe, the unseen weight that holds the cosmic structures together, and without it, the graceful motions we've been describing, the orbits, the drifts, the slow spirals, would not exist in the same way. Everything would be looser, less connected, more easily lost. So even here, in what feels like a simple question about motion, we begin to uncover something deeper. Motion is not just about movement. It is about what holds things together, what guides their paths, what allows them to continue. And as we continue to widen our view, stepping beyond the scale of stars and galaxies, we will begin to see that these motions are not random. They are part of something larger, a pattern, a flow, a quiet cosmic current that carries entire galaxies the way the Earth carries you. And somewhere within that vast, slow-moving structure, the question returns: if everything is moving, if you are moving, if even galaxies are drifting through space, then where is all of this going? For most of human history, the feeling of stillness was not questioned, it was trusted. The ground beneath your feet felt solid and unmoving. The sky above seemed to turn slowly, carrying the sun, the moon, and the stars in gentle arcs across the heavens. Day after day, night after night, the pattern repeated itself with quiet precision. And so it seemed obvious. The Earth must be still, and everything else must be moving. This idea was not foolish. In fact, it worked remarkably well. Early astronomers, watching the skies with careful attention, were able to predict the motion of planets and stars with surprising accuracy. They built intricate systems of circles within circles, delicate patterns that mimicked the wandering paths of celestial bodies. If you looked only at the results, it all seemed to make sense, but underneath, something was uneasy. The system grew more and more complicated over time. Each new observation required another adjustment, another layer, another correction. It was like trying to balance a tower of stones that never quite settled into place. And then, slowly, quietly, a different idea began to emerge. In the 16th century, a Polish astronomer named Nicholas Copernicus proposed something radical. What if the Earth was not the centre? What if, instead, it was moving, just like everything else? In his view, the sun sat calmly at the centre, and the Earth traced a path around it, along with the other planets. The strange wandering of the planets in the sky, their loops and reversals, no longer required complicated adjustments. They became simple consequences of perspective. But this new idea came with a problem. If the Earth was moving, why couldn't we feel it? It was a deeply unsettling question. After all, when you run, you feel the air against your face. When a cart accelerates, your body leans backward. Motion in everyday life comes with sensation. So why not here? Why didn't the Earth's motion create a constant wind? Why weren't we flung into space by the turning of the planet? For a long time there was no clear answer. It took another leap in understanding, built slowly over generations, to begin resolving this mystery. The key insight was deceptively simple. You do not feel motion when everything around you shares it. If you are inside a smoothly moving carriage, and the motion is steady, your body experiences no change. There is no push, no pull, no signal to indicate that anything is happening. Only when the motion changes, when you speed up, slow down, or turn, does your body notice. And the Earth's motion, as it turns and orbits, is extraordinarily smooth. There are no sudden shifts, no jolts, no sharp accelerations, just a quiet, continuous glide. This realization began to settle the question of sensation. But a deeper question remained. How do we know the Earth is moving at all? Not by feeling, but by measurement. In the 17th century, the work of Isaac Newton introduced a powerful idea that motion could be described using precise rules. Objects moved according to predictable patterns, guided by forces like gravity. Newton imagined that there existed a kind of universal stage, a fixed background against which all motion could be measured, a silent, invisible grid that defined what it meant to be truly at rest or truly in motion. For a time, This idea worked beautifully. It allowed scientists to calculate the paths of planets, predict the fall of objects, and understand the rhythms of the natural world with astonishing accuracy. But even this framework was not the final answer, because centuries later, another physicist began to question the very idea of a fixed stage. His name was Albert Einstein, and his insight was both simple and profound. There is no universal background, no absolute reference. Motion, he realized, is always relative. Imagine two travelers drifting through empty space far from any stars, any planets, any visible landmarks. They pass each other silently, each moving at a constant speed. From one traveler's perspective, they are at rest, and the other is moving. From the other's perspective, the opposite is true. Both viewpoints are equally valid. There is no experiment they can perform, no measurement they can make that would allow them to determine who is really moving. Because in a universe without reference points, motion loses its absolute meaning. This idea reshaped our understanding of the cosmos. It told us that the feeling of stillness you experience is not an illusion in the usual sense. It is simply one possible perspective. From your point of view, you are at rest. From another point of view, say from a distant galaxy, you're moving at incredible speed. Both are true, and neither is more correct than the other. But this creates a new challenge. If all motion is relative, if there is no universal standard, then how can we describe the motion of the Earth, the Sun, or the galaxy in any meaningful way? How can we answer the question we've been slowly approaching? Where are we going? To answer that, we need something subtle, not an absolute reference, but a shared one, a kind of gentle background that the entire universe agrees upon. And as it turns out, the universe itself provides exactly that, not through solid objects or fixed points in space, but through something far more delicate, a faint glow, a whisper of light left behind from the earliest moments of existence. It fills all of space, surrounding us in every direction, almost perfectly uniform, and yet with just enough variation to reveal something extraordinary. Through this quiet signal, we can begin to measure our motion, not in an absolute sense, but in relation to the universe as a whole. And when we do, we discover that we're not just moving in small local ways, not just spinning or orbiting or drifting through our galaxy. We are part of something larger, a vast coordinated motion that carries entire galaxies along invisible paths, a slow cosmic flow. And as we begin to tune into that background, to listen to that faint echo of the early universe, the question deepens, because now it is no longer just about motion. It is about direction, about currents, about destinations we cannot yet see. And somewhere within that faint glow, that ancient light, lies the first real clue to where everything is going. If you pause for a moment and gently reflect on everything we've uncovered so far, something subtle begins to settle into place. You are moving, the earth is moving, the sun is moving, and yet none of it feels like motion at all. It feels like stillness. And the reason for that, as we've begun to see, is not that motion is absent, but that motion is shared. Now let's take that idea a little further. Imagine yourself drifting on a calm lake at night. There is no wind, no waves. The surface of the water is perfectly smooth, like a sheet of glass. You're sitting in a small boat, gently floating, surrounded by darkness. Nearby, another boat drifts alongside you. At some point, the two boats begin to move past each other. From your perspective, it might feel as though you are still and the other boat is gliding away. But from the perspective of the other boat, it is you who is moving. There is no ripple in the water, no sound to guide you, No distant shoreline to anchor your sense of position. Just two objects drifting in silence. And in that quiet moment, there is no way to say who is truly moving and who is not. Both interpretations are equally valid. This is the heart of what scientists mean when they say that motion is relative. There is no single, universal answer to the question, am I moving? There is only the question, am I moving compared to what? And that small shift in perspective changes everything, because it means that motion is not an absolute property of an object. It is a relationship, a comparison between one thing and another. This idea may seem abstract at first, but it quietly shapes everything we understand about the universe. When we say the Earth orbits the Sun, we are choosing a particular frame of reference, a particular way of describing motion that makes the system easier to understand. But we could just as easily say that the Sun moves around the Earth, tracing a far more complicated path. Mathematically, both descriptions can be made to work, but one is simpler, cleaner, more natural, and so we choose it. Not because it is the only truth, but because it is the most useful one. This is something that Albert Einstein understood deeply. In his work on relativity, he took this idea of relative motion and extended it far beyond anything that had been imagined before. He realized that not only is motion relative, but time and space themselves are intertwined with that motion. Now, we won't dive into equations or complicated symbols here. Instead, we can think of it gently, like this. Imagine again that you are drifting in that quiet boat. If you begin to move faster and faster, something curious begins to happen. To someone watching from afar, your sense of time would begin to shift ever so slightly. Your movements, your processes, everything about you would unfold just a little differently compared to theirs. And yet, from your own perspective, everything would feel perfectly normal. Time would pass as it always has. This is one of the soft, almost dreamlike consequences of relativity. That motion does not just affect where you are, it subtly affects how time itself flows. But for now, we don't need to go too far into that. Because the key idea we need to hold on to is much simpler. There is no fixed stage, no invisible grid that tells us who is truly moving, no cosmic signpost that says, this is rest and that is motion. Everything depends on perspective, and yet, despite this, we still manage to talk about motion in meaningful ways. We still say that the Earth is spinning, that the Sun is orbiting the galaxy, that galaxies are drifting through space. So how do we do that? If everything is relative, the answer is that we choose reference points, not absolute ones, but useful ones. Imagine again that you are back in that boat drifting across the lake. Now imagine that, in the distance, you can see a faint shoreline. It is dim, barely visible, but it is there. Now suddenly, you have something to compare against. If you move closer to the shore, you can say, I am moving toward it. If you drift away, you can say, I am moving away. The shoreline becomes your reference. Not because it is special in any fundamental sense, but because it gives you a way to describe your motion. And this is exactly what we do in science. We look for stable, widespread, shared references that allow us to describe motion in a consistent way. Earth, we use the ground beneath our feet. In the solar system, we often use the sun. In the galaxy, we might use the center of the Milky Way. Each choice simplifies the picture, making it easier to understand, but none of them are truly absolute. They're all just perspectives. And this brings us to a quiet but important realization. The feeling of stillness you experience is not a mistake. It is simply the result of being in a shared frame of motion. You and the Earth, the air around you, the entire environment you're part of, all moving together, perfectly synchronized. like dancers in a slow, silent performance, gliding across a stage that has no edges. And because of that shared motion, everything feels calm, everything feels still. But beneath that stillness, there is movement, endless, layered, interconnected movement. And as we continue, we will begin to search for something deeper, not an absolute frame, because that does not exist, but something close, something that spans the entire universe, a faint, ancient signal that can serve as our shoreline in the cosmic ocean, a way to gently anchor our understanding of motion, not perfectly, but enough to begin answering the question that has been quietly waiting for us. If motion is always relative, then relative to the universe itself, how fast are we moving? And more importantly, in which direction? If motion is always relative, then everything depends on what you choose to compare yourself against: a shoreline, a passing boat, a distant star. Without something like that, motion becomes difficult to describe, almost impossible to pin down. And yet, as vast and empty as the universe may seem, it quietly offers us something remarkable. Not a solid object, not a fixed point in space, but something far more subtle. A kind of background, a gentle, all-encompassing glow that fills every direction you could possibly look. It is not something you can see with your eyes. It does not shine like a star or glow like a distant galaxy, but it is there, everywhere, surrounding you even now. This faint presence is known as the cosmic microwave background, and if we soften that name into something easier to feel, it is the oldest light in the universe, a quiet echo from a time when everything was much closer together, when the universe itself was young, dense, and filled with a soft, glowing fog of energy. Over billions of years, that light has stretched and cooled, fading into a whisper. Today, it is no longer visible to the human eye, but with sensitive instruments we can still detect it. And when we do, we discover something extraordinary. No matter where we look in the sky, this faint glow is almost exactly the same, almost perfectly uniform. It is as if the universe has wrapped us in a soft, even blanket of ancient light. But not perfectly. There is a tiny difference, so small that it would be easy to miss unless you knew how to look. In one direction, this background glow is just slightly warmer. In the opposite direction, it is just slightly cooler. The difference is incredibly subtle, only a few thousandths of a degree. If we were to say it gently, it is like a difference of about 3/1000ths of a degree above absolute zero, a temperature so cold that it's only just above the complete absence of heat. And yet, that tiny difference tells us something profound. It tells us that we are moving, because as we drift through this ancient sea of light, something like a gentle headwind forms in front of us. In the direction we're moving toward, the light becomes slightly compressed, slightly more energetic, slightly warmer. Behind us, the opposite happens. The light stretches out, becoming softer, cooler. It is not something you can feel on your skin, but it is something we can measure, and from that measurement, we can begin to understand our motion, not just locally, but in relation to the universe itself. When scientists carefully study this pattern, they find that our entire region of space, including the Earth, the Sun, and the Milky Way galaxy, is moving at an incredible speed. If we translate it softly, we are drifting through the universe at roughly 600 kilometers every second. Not every minute, not every hour, every second. And unlike the motions we described before, the spinning Earth, the orbit around the Sun, this motion is different. It is not part of a simple loop. It is not a closed path. It is a drift, a steady, directed movement through the cosmos, and the direction of that movement points towards something we cannot yet fully see, but something that is pulling on us all the same. Now this might raise a quiet question in your mind. If everything is relative, if there is no absolute motion, then what makes this reference, the cosmic background, special? Why can we use it? The answer is not that it is fundamentally different. It is not an absolute frame in the strict sense, but it is something close. Because this background light was created at a time when the universe was nearly uniform, before galaxies, before stars, before the complex structures we see today. It represents a kind of shared origin, a moment when everything was part of the same smooth, glowing whole. And so, when we measure motion relative to it, we are comparing ourselves to that early, balanced state of the universe. Not perfectly still, but as close as we can reasonably get. And from that comparison, something else becomes clear. Not all motion is the same. Some motion is simply the result of the universe expanding, space itself stretching, carrying galaxies away from each other. But this motion, this drift we're detecting, is different. It is a motion through that expanding space, a motion that deviates from the general flow. In cosmology, this is sometimes called a peculiar motion, but we can think of it more gently. It is a kind of wandering, a deviation from the calm outward expansion, like a leaf floating on a slowly widening river, but also drifting sideways, caught in a subtle current. And that current is what we will begin to follow. Because it is not random, it is not directionless, it has structure, it has meaning, it is shaped by something vast, something hidden, something that gathers entire galaxies and draws them along invisible paths. And as we continue, we will begin to see that this motion, this quiet drift through the cosmic background, is only the beginning. Because once we step beyond this gentle glow, we will discover that the universe is not just expanding, it is flowing, like a slow, immense ocean, with currents that carry galaxies the way the Earth carries you. And somewhere within those currents lies the answer, not just to how we move, but to where we are going. Now that we have something like a gentle cosmic shoreline, something we can compare ourselves against, the picture of motion begins to take on a little more clarity. Not perfectly sharp, but enough to notice a pattern. Because once we begin measuring how galaxies move relative to that faint, ancient glow, we discover something subtle but deeply important. Not all motion in the universe is the same. Some of it is slow and steady, shared by almost everything. And some of it is more personal, more local, shaped by nearby influences. If we soften it into simple language, there are two kinds of motion unfolding at the same time. The first is the motion of expansion. The second is the motion of drifting. Let's begin with the first. Imagine again that you're looking at a loaf of bread as it slowly rises in an oven. Inside the dough are small raisins scattered throughout. As the bread expands, the distance between each raisin increases. Not because the raisins are actively moving on their own, but because the dough itself is stretching. From the perspective of any one raisin, all the others appear to be moving away. The farther away a raisin is, the faster it seems to recede, not because it is pushing itself away, but because there is simply more dough expanding between them. This is one of the gentlest ways to picture what is happening in our universe. Space itself is stretching. It is not that galaxies are flying through empty space like sparks from a fire. It is that the space between them is slowly growing, and as it grows, it carries galaxies along with it. This is what we mean by expansion. It is a kind of shared motion, a universal background movement that affects everything on the larger scales, and it is happening everywhere, all at once. Now, here is where something interesting appears. If this expansion were the only motion in the universe, everything would move in a perfectly smooth, predictable way. Galaxies would drift apart gently, like evenly spaced points on a balloon, as it inflates. There would be no preferred directions, no currents, no flows, just a quiet, uniform spreading. But that is not what we observe. When we look more closely, when we compare the motion of galaxies to that smooth background expansion, we find that many of them are not following the pattern exactly. They are deviating. Some move slightly faster than expected, some drift sideways, some even move toward each other instead of away. These motions are small compared to the grand expansion, but they are real, and they tell us that something else is at work. This brings us to the second kind of motion, drifting, or, if we want a slightly more technical phrase, without making it heavy, motion that wanders away from the general expansion. You can imagine it like this. Return to the loaf of rising bread. The dough is expanding, carrying all the raisins apart. But now imagine that inside the dough there are tiny currents, subtle flows caused by uneven heating or differences in density. Some raisins get caught in these currents. They begin to slide gently through the dough, not just moving apart with the expansion, but also drifting in particular directions. From the outside, everything is still expanding, but locally, there are patterns, small movements layered on top of the larger one. This is very much like what happens in the universe. The expansion of space provides the broad, gentle motion, but gravity, this quiet, ever-present pull, adds something more. It causes galaxies to drift toward regions where matter is slightly more concentrated. It creates currents, flows, subtle streams of motion that guide galaxies along invisible paths. So at any given moment, a galaxy is doing two things at once. It is being carried outward by the expansion of space, and it is also drifting, pulled by gravity, nudged by the structure around it. These two motions overlap. They blend together so seamlessly that it can be difficult to separate them. But when we carefully subtract the smooth expansion, what remains is the story of these hidden currents. And those currents are what we are truly interested in, because they reveal something about the structure of the universe. They tell us that matter is not evenly distributed, that there are regions where gravity gathers things together, and regions where it lets them drift apart. They show us that the universe is not just expanding, it is organizing, shaping itself, guiding motion along certain paths, and perhaps most importantly, they begin to answer our question, where is everything going? Because once you see motion not as a single, simple process, but as the combination of expansion and drifting, you begin to realize that direction matters. Some galaxies are being pulled towards something, others are being pushed away from something. Some are caught in long, slow journeys that will take billions of years to unfold, and some will never reach their apparent destinations at all. The universe, it seems, is not just getting bigger, it is flowing, like a vast, slow-moving ocean, where the water itself is rising, and within it, gentle currents carry everything along. And just like an ocean, if you want to understand where something will end up, you cannot look only at the surface. You have to understand the currents beneath. So as we move forward, we will begin to trace those currents, to see where they lead, to understand what shapes them, and to follow the path, not just of a single planet or a single star, but of entire galaxies, because somewhere within that layered motion, within that quiet combination of expansion and drift, lies the deeper answer. Not just that everything is moving, but that everything, yes, is moving somewhere. If you follow those quiet currents just a little further, something begins to come into view. At first it is not obvious, because when you look up at the night sky, what you see feels scattered. Stars appear as isolated points of light. Galaxies, even through powerful telescopes, seem like distant islands, separated by enormous stretches of darkness. It feels empty, disconnected. But that impression is only a surface illusion. Because when we step back, far beyond what the eye can see, and begin to map the positions of galaxies across vast distances, a different picture slowly emerges. Not a random scattering, but a pattern, a structure, a kind of hidden architecture that stretches across the universe. This structure is known as the cosmic web, and if we soften that name into something more familiar, you can imagine it as a vast, delicate network, like strands of silk floating in darkness, or like the faint pattern of cracks that spread across a frozen lake, thin branching lines connecting distant points. Along these strands, these long thread-like regions, galaxies gather. They are not evenly spread out, they cluster, they align, they form chains and filaments that stretch across hundreds of millions of light years, and where these filaments intersect, you find something even more remarkable. Dense regions where thousands of galaxies come together, bound by gravity into enormous clusters. These are like the knots in the web, bright, crowded intersections where matter has collected over billions of years, and between the strands, there are vast empty spaces, regions so devoid of matter that they contain almost nothing at all. These are known as cosmic voids, but again, we can think of them more gently. They are the quiet spaces between the threads, the open gaps where very little exists. Now, once you begin to see the universe this way, not as scattered points, but as a connected web, something important becomes clear. Motion is not random. Galaxies are not drifting aimlessly. They are moving along these structures, sliding slowly through the filaments, falling toward the dense knots, avoiding the empty voids. It is as if the universe has laid down invisible pathways, and everything is following them. To picture this more softly, imagine rain falling on a vast landscape. At first, each drop falls independently, but once it reaches the ground, something changes. The water begins to gather. It flows downhill, following subtle slopes and hidden contours. Small streams form, then rivers, all of them guided by the shape of the land. In the same way, galaxies follow the shape of the universe, not a shape made of solid ground, but a shape defined by gravity, a landscape of invisible hills and valleys, where the valleys, regions of higher mass, draw galaxies inward, and the hills, regions of emptiness, allow them to drift away. And this brings us to something even deeper, because this structure, the cosmic web, did not appear suddenly. It grew, slowly, over immense stretches of time. In the early universe, matter was spread out almost evenly, not perfectly, but very close. There were tiny variations, slight differences in density, barely noticeable. But over time, those small differences began to matter. Regions that were just a little denser than average began to pull in more material, and as they gathered more mass, their gravitational pull grew stronger, which allowed them to gather even more. It was a quiet process, a slow amplification, like a whisper that gradually becomes a voice, or a ripple that grows into a wave. Over billions of years, those slight variations evolved into the vast structures we see today. Filaments, clusters, voids, the cosmic web. And within that web, motion became organized. Instead of moving randomly, galaxies began to follow the contours of this structure, flowing along filaments, falling into clusters, drifting away from emptiness. And so, the question of where everything is going becomes more focused. It is no longer just about expansion. It is no longer just about drifting. It is about direction within a structure, a network that guides motion on the larger scales. Now, there is one more layer to this that makes it even more fascinating, because the structure we see, the glowing galaxies, the bright clusters, is only part of the story. Beneath it, there is something else, something that does not shine, something that does not interact with light, but something that shapes the entire web. This is what we call dark matter, and while we will explore it more deeply soon, for now it is enough to think of it like this. If the cosmic web is a vast glowing structure of galaxies, then dark matter is the invisible framework beneath it, the hidden scaffolding that holds everything in place. It is what gives the web its shape, what determines where the filaments form, what guides the motion of galaxies along those paths. Without it, the universe would look very different, less structured, less connected, less guided. So when we look out into the cosmos, what we are really seeing is only the visible surface of something much deeper, a vast layered system where visible matter traces out the shape of something unseen, and where motion follows paths laid down long before galaxies even existed. And as we continue, we will begin to follow those paths more closely, to trace the flow of galaxies along the filaments, to see where they gather, to understand what lies at the intersections, because somewhere within this immense web, there are regions that act like destinations, places where motion converges, where entire groups of galaxies are slowly being drawn together, and if we follow those currents carefully enough, we may begin to answer the question that has been quietly guiding us all along, not just that everything is moving, but where, within this vast and intricate web, everything is heading. If you keep your attention on that vast, delicate web for just a moment longer, something curious begins to stand out. The pattern is there. The filaments, the clusters, the quiet empty spaces in between. It all feels structured, intentional almost. But if you look closely at what we can actually see, the stars, the glowing gas, the galaxies themselves, something doesn't quite add up. There isn't enough. Not enough visible matter to explain the shape of the web. Not enough to hold galaxies together the way we observe. Not enough to guide motion with the strength that we measure. It is as if you are looking at the outline of something, but the substance that gives it form is missing. And this realization did not come all at once. It arrived slowly through careful observation, through small inconsistencies that refused to disappear. One of the earliest clues came from the motion of stars within galaxies. If you imagine a galaxy like a vast rotating disk, something like a spinning wheel of light, you might expect the stars near the center to move faster and the stars farther out to move more slowly. This is how things behave in many familiar systems. Planets closer to the sun move faster than those farther away. Objects held by gravity tend to slow down as the distance increases. But when astronomers measured the motion of stars in galaxies, they found something unexpected. The outer stars were not slowing down. They were moving just as fast as those closer in. And if we describe it gently, without equations, it was as though the outer edges of the galaxy were being held in place by something stronger than what we could see. Without that extra pull, those stars should have drifted away long ago, but they hadn't. They remained bound, held together by something invisible. And so, a new idea began to take shape, that there must be additional matter, unseen but present. Matter that does not shine, does not emit light, does not interact with us in the usual ways, but still exerts gravity, still shapes motion. This is what we now call dark matter. Not because it is dark like the night sky, but because it is hidden from direct observation. We cannot see it, We cannot touch it, but we can infer its presence through the way things move. And once this idea was introduced, it began to appear everywhere, not just within individual galaxies, but in clusters of galaxies, in the way galaxies group together, in the very structure of the cosmic web itself. It became clear that what we see, the stars, the glowing gas, the bright galaxies, is only a small part of what is actually there. If we could somehow weigh the universe, not just the visible parts, but everything, we would find that most of the mass is invisible, a vast unseen component that outweighs the luminous matter by several times, and it is this invisible mass that forms the true backbone of the cosmic web. If you imagine the web again, the glowing filaments you see are like dewdrops clinging to invisible threads, beautiful, delicate, but only outlining something deeper. The real structure, the threads themselves, is made of dark matter. It stretches across the universe, forming a hidden network of gravitational influence, and it is along these invisible strands that galaxies form, that they gather, that they move. So when we say that galaxies follow the filaments of the cosmic web, what we are really saying is that they are following the distribution of dark matter. They're tracing out a structure that we cannot see directly, but can understand through its effects. And this changes how we think about motion in a profound way. Because now, motion is not just about expansion, or even about local gravitational pulls. It is about navigating a landscape defined by something unseen, a hidden terrain, a set of invisible valleys and ridges carved into the fabric of the universe. Galaxies drift along these valleys, drawn toward regions where dark matter is more concentrated. They avoid the ridges, the higher regions where matter is sparse, and over time this creates flow, not chaotic, motion, but guided motion, directed motion, motion with a sense of destination. But there is something even more subtle happening here, because dark matter does not only shape where galaxies are, it also shapes where they are going, the paths they follow, the flows they become part of. Entire groups of galaxies are drawn together along these invisible gradients. Clusters grow larger as they pull in more and more matter. Filaments channel material toward these dense regions, like rivers feeding into a vast ocean. And all of this unfolds slowly, over billions of years, with no urgency, no sudden changes, just a quiet, persistent movement toward regions of greater gravitational pull. And yet, even this is not the whole story, because if dark matter were the only force shaping the universe, something very different would happen. Over time, gravity would pull everything together. Galaxies would merge, clusters would grow larger and larger. Eventually, everything might collapse into enormous structures. The web would tighten. The universe would become more connected, more concentrated. But that is not what we see. There is another force at work, a force that does not pull, but pushes. A force that works against gravity slowly but steadily. A force that becomes more important as time goes on, and this force will change everything. It will alter the paths of galaxies, prevent certain journeys from ever being completed, and reshape the future of the cosmic web itself. So even as dark matter builds the structure, even as it guides motion along invisible pathways, there is something else, quietly waiting in the background, something that will eventually overpower this gentle gathering. And when it does, the currents we are beginning to trace will change. The destinations we imagine may no longer be reachable, and the question we have been following, where everything is going, will take on a very different meaning, because the universe is not only shaped by what pulls things together, but also by what drives them apart. If you let your thoughts rest for a moment on that invisible structure, that quiet web shaped by unseen mass, something even deeper begins to reveal itself. Because the cosmic web is not just a pattern in space, it is a memory, a fossil, a record of something that happened long, long ago, before galaxies, before stars, before even the first atoms had fully settled into place. To understand this, we have to gently travel backward in time, not in a dramatic way, just a slow drift, back toward the early universe. There was a time when everything was much closer together. The universe was smaller, denser, and filled not with stars and galaxies, but with a hot, glowing mixture of particles, light and matter tangled together in a kind of luminous fog. In that early state, nothing could travel freely. Light could not move in straight lines. It was constantly scattered, bouncing from particle to particle, unable to escape. But within that dense, glowing medium, something was happening. There were tiny variations, small differences in density, regions that were just slightly more crowded than others. And in those regions, pressure began to build. If we soften the idea into something more familiar, it is like sound. When you speak, your voice creates waves, compressions and expansions in the air that travel outward. In the early universe, something very similar was happening, except instead of air, the waves moved through this hot, dense mixture of matter and light. These were gentle ripples, expanding and contracting, pushing outward, then falling back inward, over and over again. And these ripples had a rhythm, a natural scale, a kind of preferred distance that they would travel before slowing and reversing. Now, we don't need to describe this with equations. We can think of it simply as a kind of pulse, a wave that moved outward like a ripple in a pond carrying matter along with it. And then, something changed. As the universe expanded and cooled, it reached a moment when light could finally travel freely. The fog lifted, the particles settled, and those ripples, they froze in place. Their motion stopped, but their imprint remained, like the faint rings left behind after a stone is dropped into still water. These ancient ripples are what scientists refer to as baryon acoustic oscillations, but we can think of them more gently, as echoes from the earliest moments of the universe, still visible today, not as sound, but as structure. If you look at the distribution of galaxies across the universe, you can detect a subtle pattern, a slight preference for galaxies to be separated by a certain distance, a faint, almost invisible shell-like structure that repeats across space. It is as if the universe still carries the memory of those early waves. And one of the most beautiful discoveries in recent years has been the identification of a vast structure spanning hundreds of millions of light years that appears to trace out one of these ancient ripples, a kind of cosmic ring, a frozen wave, a whisper from a time when the universe itself was still finding its shape. And what makes this so remarkable is not just that it exists, but that it still influences motion today. Because those early ripples created slight differences in density, and those differences became the seeds of everything that followed. Regions that were just a little denser became the starting points for galaxies, for clusters, for the filaments of the cosmic web, and once again, gravity began its quiet work, amplifying those differences, pulling matter inward, guiding motion along the paths defined billions of years earlier. So when we look at the motion of galaxies today, we are not just seeing what is happening now, we are seeing the continuation of something that began almost at the very beginning of time, a process set in motion by those early ripples, a flow that has been unfolding ever since. And this adds a new layer to our understanding, because motion is not just shaped by present forces, it is shaped by history, by the conditions of the early universe, by events that took place long before the Earth even existed. It is as if every galaxy carries with it a memory, a subtle imprint of the past that influences where it goes and how it moves. But there is something even more gentle hidden within this idea. Because these ripples, these ancient echoes, they were not random. They followed simple physical rules, patterns that emerge naturally from the behavior of matter and light, which means that, in a quiet way, the large-scale structure of the universe, the cosmic web, the flows of galaxies, the destinations we are beginning to trace, all of it was already hinted at in those earliest moments, not in detail, not in exact form, but in possibility, in potential, like the first notes of a melody that would take billions of years to fully unfold. And we are still listening to that melody now, still tracing its shape, still following its rhythm, as galaxies drift along the filaments, as clusters grow, as motion continues across unimaginable distances. All of it is connected back to those first ripples, those first movements, those first gentle waves in the fabric of the universe. And as we continue, something begins to come into focus. Because these ripples did not just create structure, they help define direction. They help shape the pathways along which galaxies would move. And if we follow those pathways carefully enough, we begin to see something remarkable. The motion of galaxies is not just outward, not just drifting apart, but also inward, towards certain regions, towards certain gathering points, places where the flow of the universe seems to converge. And as we follow that convergence, that quiet gathering of motion, we begin to approach something new, something hidden, something powerful, a region that pulls not just a few galaxies, but entire groups of them, a place that for a long time we could not see at all, but whose presence we could feel through motion alone, and it is there, in that unseen pull, that our next step awaits. As we follow these quiet currents a little further, something begins to gather in the distance, not something you can see clearly, not something that shines or announces itself, but something you can feel through motion alone. Because when astronomers began mapping the movement of galaxies around us, carefully measuring their speeds, their directions, their subtle drifts, they noticed a pattern. It was not random. It was not evenly spread. Many galaxies, including our own, seem to be moving in roughly the same direction, as if caught in a slow, immense current, a flow that stretched across tens of millions of light years. And when they traced that flow, backward, following it like a river upstream, it pointed toward a particular region of the sky, a place hidden behind the dense clouds of dust and gas in our own galaxy, a region we could not easily see, but one that seemed to be pulling on everything around it. This mysterious region came to be known as the Great Attractor, and if we soften that name into something more intuitive, you can imagine it as a kind of valley, not a valley made of earth and stone, but a valley in the invisible landscape of gravity, a place where the pull is stronger, where matter tends to drift inward, where the quiet motion of galaxies begins to converge. Now, this is not a sudden fall. There is no rushing, no collapse, no dramatic plunge. The motion is slow, measured in millions, even billions of years, but it is steady, persistent, like water gradually finding its way downhill. And our galaxy, the Milky Way, is part of that flow. We're not standing still in the cosmic web. We are moving along one of its strands, drifting ever so gently toward this hidden region, and we are not alone. Thousands of galaxies in our cosmic neighborhood are doing the same, all of them following similar paths, all of them subtly drawn in the same direction. It is as if we are part of a vast migration, a slow procession through space, guided not by intention, but by gravity. Now, what makes the Great Attractor especially fascinating is that for a long time, We could not see it at all. It lies in what astronomers call the zone of avoidance, a portion of the sky obscured by the dense disk of our own galaxy. The stars, gas and dust of the Milky Way block our view, like a thick fog hiding the landscape beyond. And so, for decades, the Great Attractor was known only through its effects, through the way galaxies moved, through the way our own galaxy drifted. It was a presence inferred, rather than observed, a kind of gravitational shadow. But over time, with the help of different kinds of light, radio waves, infrared observations, X-rays, astronomers began to peer through that obscuring veil. And what they found was not a single object, not a lone dominant structure, but a region rich with mass, clusters of galaxies, dense concentrations of matter, all contributing to the gravitational pull we've been detecting. At the heart of this region lies a massive cluster of galaxies, often associated with what we call the Norma cluster, a gathering of galaxies far larger than most others in our vicinity, a place where gravity has had billions of years to collect and concentrate matter. And it is toward this region that our motion is directed. But here, something subtle begins to shift. Because while the Great Attractor feels like a destination, it may not be one. The distance between us and this region is immense, hundreds of millions of light years. Even at the quiet but steady pace of our motion, moving at over 100 kilometers each second in that direction, it would take far longer than the current age of the universe to reach it. And yet, even as we move toward it, there are hints that the story is more complicated, because when astronomers look carefully at the strength of the pull, at the speed of our motion, they find that the Great Attractor alone may not be enough to explain everything. It is as if the valley we are descending into is part of a larger landscape, a deeper structure that extends beyond what we can easily see. And this introduces a new layer of mystery, because it suggests that the flow we are following does not end here, that the Great Attractor is not the final destination, but perhaps only a waypoint, a local convergence within a much larger current. And if that is true, then our journey is longer than we imagined, more complex, more layered, because now, instead of asking, are we moving toward something, we begin to ask, what lies beyond it? What could be large enough, distant enough, to influence not just our galaxy, but the motion of entire regions of the universe? And as we continue, we will begin to widen our view once more, to step back from this hidden valley and see the larger structure it belongs to. Because the Great Attractor, as powerful and mysterious as it is only a part of something much greater, a vast region of space where galaxies flow together, not just into one point, but along a network of currents that stretch across unimaginable distances. And as we follow those currents outward, the picture will grow larger, the motion will become clearer, and the question we've been carrying will deepen once again. Because if everything is moving toward something, then what happens when even that something is also moving? If you hold that image in your mind for just a little longer, a vast quiet flow of galaxies drifting toward a hidden valley, something begins to gently shift, because the more carefully we look at that motion, the more it begins to feel incomplete, not incorrect, but unfinished, as though the story does not end at the Great Attractor, but continues beyond it, stretching further into the unseen. And so, once again, we take a step back, not physically, but in perspective. We widen the view, we allow the scale of our thinking to expand just a little more, and as we do, something remarkable begins to appear. The motion we've been tracing, the drift of galaxies toward the Great Attractor, is not isolated. It is part of a much larger pattern, a broader flow, a structure that spans hundreds of millions of light years, a structure that includes not just our galaxy, but tens of thousands of others. This structure is known as the Laniakea supercluster, and if we soften that name into something more intuitive, it is like a vast basin, an immense region of space where galaxies are not scattered randomly, but are gently flowing toward a shared center. The name itself, drawn from the Hawaiian language, can be understood as something like immense heaven or open skies. And it is fitting, because Laniakea is not a single object. It is not a tightly bound structure. It is not something you could draw a clear boundary around. Instead, it is defined by motion, by the way galaxies move, by the way their paths converge. And this is what makes it so beautiful, because instead of defining structure by position, we define it by direction, by flow. Imagine again that landscape we spoke of earlier, a terrain shaped not by hills and valleys of Earth, but by the invisible pull of gravity. Now imagine rain falling across that entire landscape, each drop finding its own path, some flowing into small streams, others into larger rivers, and eventually, all of them making their way toward a shared low point. A basin. Laniakea is like that basin. A region where the motion of galaxies, when traced over time, reveals a shared destination. And within this vast basin, we can begin to see layers. Because motion in the universe is not simple. It's not a single journey. It is layered, nested, built from smaller motions within larger ones. Our galaxy, the Milky Way, is part of a small group of galaxies known as the local group. This includes our closest large neighbour, the Andromeda Galaxy, along with dozens of smaller galaxies bound together by gravity. Within this group, motion is intimate, close. Galaxies orbit one another, interact and slowly drift together. This is a local dance, a small-scale motion shaped by nearby gravity. But the local group itself is not isolated, it is moving, drifting toward a larger structure known as the Virgo cluster, a dense collection of thousands of galaxies. And so now the motion becomes layered. The Milky Way moves within the local group. The local group moves toward the Virgo cluster, and the Virgo cluster, along with many others, participates in the larger flow of Laniakea, each level nested within the next, each motion embedded within a greater one. It is like being carried by a river that flows into a larger river, which eventually joins an even greater current, and at each level the motion feels complete, but from a broader perspective, it is only part of something larger. And this realization changes how we think about where we are going, because the answer is no longer a single destination. It is a hierarchy, a sequence of movements, a layered journey. At one level we are moving toward Andromeda, at another toward the Virgo cluster, at a larger scale toward the center of Laniakea. All of these are true, all of them happening at once, and yet, even this is not the end. Because as astronomers continued to map these flows, using careful observations and subtle measurements of motion, they began to notice something even more intriguing. The center of Laniakea, the region toward which all these galaxies seem to drift, is not perfectly still. It too appears to be moving. And this brings us to a quiet but profound shift in perspective. Because what once seemed like a destination now begins to look like just another part of a larger journey. The basin itself may not be the lowest point. The river may not end here. And so, once again, the scale expands, the story grows, the motion deepens. Because if Laniakea is moving, then something beyond it must be influencing that motion. Something larger, more distant, more powerful. And so the question returns, softer now, but more profound, not just where are we going, but how far does this flow extend? How many layers are there? How many currents are nested within currents? Because each time we think we've found the destination, the universe gently reveals something beyond it, something that pulls on everything we've just discovered and carries it further still. And as we follow that expanding trail, as we allow our perspective to widen once more, we begin to approach a deeper truth. That motion in the universe is not a straight path, not a simple journey from one point to another, but a cascade, a series of flows, each embedded within a larger one, and somewhere within that cascade, somewhere beyond even the vast basin of Laniakea, there lies the next piece of the story, a greater pull, a deeper current, and perhaps a destination that is not what we expect. If you continue to widen your view, letting your awareness drift outward beyond our galaxy, beyond our local group, beyond even the vast basin of Laniakea, something unexpected begins to appear. At first, it is only a subtle suggestion, a quiet imbalance, a sense that the motion we've been following, the flow toward the Great Attractor, the convergence within Laniakea, is not quite enough to explain everything. Because when astronomers measure how fast galaxies are moving, when they carefully track the direction and strength of that motion, they find something curious. The pull we observe feels stronger than it should be, as though something else is contributing, something further away, something even larger. And so, once again, we follow the motion. We trace the currents outward, beyond the regions we've already explored, and into deeper, more distant structures. And there, slowly, quietly, another presence emerges, a vast concentration of galaxies far beyond our local supercluster, a structure so large, so massive, that its influence extends across hundreds of millions of light years. This is the Shapley supercluster. And if we soften that name into something more intuitive, you can imagine it as a deeper valley, a more distant basin, a region of even greater gravitational pull, lying beyond the one we thought we were heading toward. Now, this is not something we are falling into directly. Not in any immediate sense. The distances involved are immense. Even at the quiet but steady pace of our motion, it would take far longer than the current age of the universe to reach it. But its presence matters, because gravity does not require closeness to act. It extends, it reaches, it influences motion across vast distances. And so, even from afar, this immense structure contributes to the flow we observe. It adds its weight to the cosmic landscape. It deepens the valleys. It reshapes the currents. And suddenly, the picture becomes more layered. The Great Attractor is no longer the final destination. It is part of a chain, a sequence of gravitational influences, a hierarchy of pull, where smaller structures flow toward larger ones, and those larger ones are themselves drawn towards something even greater. It is like a series of rivers. A small stream flows into a river. That river flows into a larger river, and that river eventually moves toward an ocean. At each step, the motion feels complete, but from a wider perspective, it is only part of a longer journey. And yet, even this may not be the full story, because there are hints, subtle, uncertain, but intriguing, that the motion of galaxies might extend even beyond what we can easily explain. Some observations have suggested the possibility of a large-scale drift, a motion that affects entire clusters of galaxies across enormous distances, a kind of shared movement in a particular direction. This idea has been referred to in some studies as a dark flow, but we must approach it gently, because the evidence is not fully settled. Some observations suggest it may be there, others find no clear sign of it, and so, rather than treating it as a confirmed feature, we can think of it as a possibility, a reminder that our understanding is still incomplete, that there may be motions, influences, structures that we have not yet fully uncovered, and in a way, this uncertainty is part of the story, because it tells us that this universe is still revealing itself, still offering new layers of complexity, still inviting us to look deeper. But even without this uncertain motion, even if we consider only what we know with confidence, something important has already become clear. There is no single center, no ultimate destination where everything comes to rest. Instead, there is a network of influences, a cascade of motion, a hierarchy of structures, each shaping the movement of those within it. And as we follow this cascade, from the Milky Way, to the local group, to the Virgo cluster, to Laniakea, to the Shapley supercluster, we begin to see a pattern. Each time we think we have found the end of the journey, the universe gently extends it. Each destination becomes a waypoint, each answer becomes a deeper question, and this leads us to a quiet but profound realization. The motion we are tracing is not converging toward a single point. It is unfolding across scales, layered, nested, endless. And yet, something else begins to emerge as well. Because so far, everything we have described has been about pulling, gravity drawing galaxies together, structures forming, flows converging. But there is another side to this story, a quieter force, but one that becomes more important with time, a force that does not pull inward, but pushes outward, a force that acts most strongly in the emptiest regions of space. And as we begin to consider this force, as we shift our attention from the dense clusters to the vast voids between them, the direction of motion begins to change, not completely, but subtly, because now it is not just about where things are being pulled, but also about where they are being pushed away from. And this changes everything, because it means that motion in the universe is not just guided by attraction, but also by repulsion, not just by gathering, but by separation. And as we move forward, we will begin to explore this other side of the cosmic story, the quiet influence of emptiness, the hidden push of the void, and how, over time, it begins to reshape the destiny of everything we have been following. Because in the end, the journey of the universe is not just about where things are going, but about what prevents them from ever arriving. Up to this point, the story has felt like a quiet gathering, galaxies drifting along filaments, clusters pulling matter inward, vast regions of space acting like gentle valleys, drawing everything toward them. It has been a story of attraction, of gravity guiding motion, shaping the paths of everything we see. But if you sit with that image for just a moment longer, something begins to feel incomplete. Because if gravity were the only force at work, then over time, everything would slowly come together. The currents would all converge, the valleys would deepen, and eventually, the universe would become more connected, more concentrated, more unified. But that is not what we observe. There is another influence at play, a quieter one, less obvious at first, but no less important. And to begin to see it, we have to gently shift our attention, not toward the bright clusters, not toward the dense filaments, but toward the emptiness, toward the vast silent regions between the threads of the cosmic web. These regions are known as voids, and at first glance they seem like nothing, empty spaces, places where very little exists. But in the universe, emptiness is never truly empty, and in fact, these voids may be some of the most active regions of all. To understand why, imagine once again that vast landscape we've been using to guide our intuition. A terrain shaped by invisible hills and valleys. So far we have focused on the valleys, regions where matter gathers, where gravity pulls inward. But now imagine the opposite. Wide, open plateaus, regions where there is very little mass, very little gravity to hold things together. If you were to place a drop of water in such a region, it would not stay. It would drift outward, away from the emptiness, toward the nearest valley. And in the universe, something very similar happens. Galaxies near the edges of these vast voids tend to move away from them, not because the void is actively pushing in a mechanical sense, but because there is nothing there to hold them. No significant mass, no strong gravitational pull, and so, by comparison, the surrounding regions, where matter is more concentrated, begin to draw galaxies away. The result feels like a push, a gentle outward motion from emptiness towards structure. And when astronomers began mapping these motions carefully, something remarkable emerged. It appeared that our own galaxy is not only being pulled toward regions like the Great Attractor, but also being influenced by a vast region of emptiness in the opposite direction. A kind of cosmic void, so large and so underdense, that it plays a role in shaping the motion of entire galaxy flows. This region has been given a name, the dipole repeller, and if we soften that name into something more intuitive, you can imagine it as a great empty expanse, a region of space where matter is sparse, where structure is minimal, where the gravitational pull is weak. And because of that, galaxies near its boundaries tend to drift away, as if gently repelled. Now, it is important to understand this carefully. The void is not pushing in the way a force pushes an object. There is no wind, no pressure, no physical shove. Instead, it is the absence of pull, combined with the presence of stronger pulls elsewhere, that creates the effect. It is a relative motion, a balance of influences. But from the perspective of motion, the result is clear. Galaxies move away from voids and toward regions of higher density. So now, the picture of motion becomes more complete. It is no longer just about attraction. It is about contrast, about differences, about the interplay between where matter is and where it is not. We are pulled toward clusters, toward dense regions, toward the Great Attractor and beyond. And at the same time, we are also, in a sense, pushed away from vast regions of emptiness. And this dual influence, pull and push, creates the currents we observe. It shapes the flow of galaxies across the cosmic web. It defines the paths they follow. And it gives motion a kind of directionality, a sense of movement that is guided not by a single force, but by a balance. To picture it more gently, imagine floating in a slow-moving river. There are currents pulling you forward, guiding you along a path, but there are also eddies and regions of stillness behind you, areas you naturally drift away from. You're not being pushed from behind, but the shape of the flow ensures that you move forward, and this is how motion in the universe unfolds, not as a single simple force, but as a combination, a quiet interplay between attraction and absence, between structure and emptiness, and yet there is something even deeper hidden within these voids, because they are not just regions of low matter, they are regions where something else becomes more important, something that we have not yet fully explored, a subtle property of space itself, a quiet influence that becomes stronger, the emptier space becomes, and this influence does something remarkable. It does not simply allow expansion, it accelerates it. So as we move forward, as we continue to follow the flow of galaxies, we will begin to see that these voids are not just passive regions. They are active participants in the evolution of the universe, places where a deeper force begins to dominate, a force that will, over time, reshape the destiny of everything we have been tracing. Because in the end, it is not just the pull of gravity that determines where things are going, it is also the quiet, persistent influence of emptiness, an influence that does not gather but separates, that does not converge but expands. And as we begin to explore that influence more fully, the story of motion will take on a new tone, one that is quieter, more subtle, but also more final. Because what we are about to encounter will change not just where things are going, but whether they can ever arrive at all. If you rest your attention on those vast, quiet voids for a moment longer, they begin to feel different. At first, they seemed like nothing, empty gaps between the threads of the cosmic web, silent spaces where very little happens. But now, they begin to feel active, not dramatic, not violent, but quietly influential. Because the more we understand these regions, the more we realize that emptiness in the universe is not simply the absence of matter. It is something else, something with its own subtle presence. To begin to sense this, imagine a simple thought experiment. Picture a box, completely empty. No air, no dust, no particles, nothing at all. At least, that is how we might imagine it. But in reality, even such a box is not truly empty. Modern physics tells us that what we call empty space is not a void in the absolute sense. It is more like a restless background, a quiet field of energy, always present, always there. Not something we can see, not something we can touch, but something that exists nonetheless. And this becomes important when we think about the universe as a whole, because as the universe expands, it creates more space, more of this emptiness, more of this subtle background, and with that, something unexpected happens. The influence of this empty space does not fade, it grows, not in intensity per unit space, but in total effect, because there is simply more of it. And this brings us to a concept that has quietly reshaped our understanding of the cosmos, something known as dark energy. But instead of treating it as a technical term, we can think of it more gently, as a property of space itself, a tendency for space to expand, not just passively, but actively, to stretch, to grow, to widen the distances between things. Now, this expansion is not new. We have already seen that the universe has been expanding for billions of years, galaxies drifting apart as space itself stretches. But for a long time, this expansion was slowing down. Gravity, the pull of matter, was working against it, trying in its quiet way to bring things back together. But something changed. About 5 billion years ago, a shift occurred. The universe had expanded enough that matter became more spread out, more diluted. Its gravitational pull weakened over large scales, and in that quiet weakening, something else began to dominate. This subtle property of space, this tendency to expand, began to take over. And from that moment on, the expansion of the universe did not just continue, it began to accelerate. If we soften the image, it is as if the universe had been coasting, slowly slowing down under the pull of gravity, and then, gently, almost imperceptibly at first, it began to speed up again. Not because something pushed it from outside, but because space itself was driving the expansion from within. And this is where the voids become especially important, because the influence of this expansion is not uniform in the way we might expect. It becomes strongest where matter is weakest, in the voids, in the vast empty regions between filaments, because there is very little gravity there to resist it, nothing to hold things together, nothing to slow the stretching of space. And so, in those regions, expansion unfolds more freely, more purely, more strongly. The voids grow, they widen, they push the surrounding structures apart, not through force in the usual sense, but through the quiet, persistent expansion of space itself. And as they grow, they begin to merge. Small voids combine into larger ones. The empty regions expand, connecting with each other, forming vast, open expanses that dominate more and more of the universe. And in doing so, they reshape the cosmic web. They stretch the filaments. They separate clusters. They make the distances between structures grow faster and faster. So now, when we think about motion in the universe, we must include this new influence, not just gravity pulling things together, not just the initial expansion carrying things apart, but a deeper, accelerating expansion driven by the nature of space itself. And this changes the story in a fundamental way, because earlier it seemed as though galaxies might eventually gather. That flows toward regions like the Great Attractor might one day complete, that the cosmic web might tighten, becoming more connected over time. But now, a different future begins to emerge, one where the expansion does not slow, but continues to accelerate, where voids grow larger and larger, where the distances between structures increase more and more rapidly, and where certain journeys, certain flows, certain destinations become unreachable, not because the paths disappear, but because the space between points stretches too quickly, like trying to walk toward a distant horizon, while the ground beneath you is being stretched outward faster than you can move. You continue walking, you continue moving forward, but the destination never gets closer, and slowly, gently, it begins to drift away. And this is where the story of motion begins to take on a different tone, because now it is no longer just about where things are going. It is about whether they can ever arrive, because the same force that expands the universe also separates it. It pulls structures apart, not by force, but by the quiet, relentless growth of space. And in the emptiest regions, where this effect is strongest, we begin to see the future unfolding, a future where the cosmic web stretches, thins, and slowly begins to unravel. And as we move forward, we will begin to explore that future more directly, because there is a moment, a turning point, when this expansion becomes the dominant influence, when gravity no longer guides the large-scale fate of the universe, when the currents we have been following begin to change, and when the journey we imagined quietly slips out of reach. If you stay with that image of space itself quietly stretching, of voids widening, of galaxies drifting farther apart, something begins to settle into place. A turning point, not a dramatic moment, not something that happened suddenly, but a slow shift, unfolding over billions of years, a change in balance, because for much of the universe's history, gravity was in control, not completely, but enough to slow the expansion, enough to draw matter together, enough to shape the formation of galaxies, clusters, and the vast web we've been following. In those earlier times, the universe was smaller, denser, matter was packed more closely together, and because of that, its gravitational pull was stronger, more effective, more capable of influencing motion across large distances. If you imagine the universe then, it would feel more connected, more tightly woven, galaxies closer to one another, flows more likely to converge, paths more likely to complete. But as time passed, something quiet began to change. The universe continued to expand, space stretched, distances grew, And as they did, matter became more spread out, more diluted, its influence weakened, not because gravity itself changed, but because the things creating gravity, mass, were now farther apart. And in that quiet dilution, something else began to emerge, something that had always been there, but had been too subtle to dominate. That property of space we spoke of earlier, that gentle tendency to expand. At first, it was almost insignificant, a faint background effect, but as matter thinned out, its relative influence grew until, slowly, quietly, it reached a point where it could no longer be ignored. About 5 billion years ago, the balance shifted. Gravity, which had been slowing the expansion, began to lose its hold, and this other influence began to take over. From that moment on, the expansion of the universe did not simply continue, it accelerated. If we soften the image, it is like watching a ball roll upward along a gentle slope. At first, it slows as gravity pulls it back. You might expect it to stop and begin to roll downward again, but instead, something unexpected happens. The slope itself begins to change. It tilts ever so slightly, and the ball, instead of stopping, begins to speed up again, not because it was pushed, but because the underlying landscape shifted. This is what happened to the universe. The landscape of space-time itself changed in its effect. Expansion, once resisted by gravity, became self-reinforcing, and as it did, the future of the universe began to take on a new shape, because now, the large-scale motion of galaxies was no longer governed primarily by attraction. It was governed by separation. The currents we traced earlier, the flows toward clusters, toward the Great Attractor, toward deeper structures, they didn't disappear, but they began to weaken. Over vast distances, the accelerating expansion began to dominate. Galaxies that were not already bound together began to drift apart more rapidly. The space between them stretched faster and faster, and the influence of gravity, though still present, became less effective at pulling distant structures together. So now, when we ask where everything is going, the answer becomes more subtle. On small scales, gravity still rules. Galaxies within clusters remain bound. The local group, our Milky Way and its neighbouring galaxies, continues its slow, inevitable interactions. Even the future merger between the Milky Way and Andromeda will still take place. Because within these smaller regions, gravity is strong enough to overcome the expansion. But on larger scales, between clusters, between superclusters, the story changes. Those vast distances, those enormous separations, they are now dominated by expansion, and that expansion is accelerating, which means that over time, structures that are not already connected will become increasingly isolated. The cosmic web, which once guided motion across immense distances, will begin to stretch, to thin, to lose its ability to bring distant regions together. And this leads to a quiet but profound realization. The universe has entered a new phase, a phase where the large-scale structure is no longer growing in the same way, where new connections between distant regions are no longer being formed, where the flows we have been following are slowly being disrupted, not violently, not suddenly, but inevitably. And this changes the meaning of motion, because before, motion felt like a journey, a movement towards something, a convergence, a gathering. But now, motion becomes something else, something more open-ended, more uncertain, because even as galaxies continue to move, even as they follow the currents laid out by the cosmic web, the space between them is expanding faster than those currents can carry them together. And so, in a quiet and almost imperceptible way, destinations begin to slip out of reach. Paths that once seemed possible begin to stretch, to elongate, to drift apart, and the universe, instead of becoming more connected over time, begins to move in the opposite direction, toward separation, toward isolation, toward a future where each region becomes more and more distant from the others. And as we move forward, this realization will deepen, because the next step in this story is not just that expansion has taken over, but that it will continue, unstoppable, persistent, quietly shaping the fate of everything we have been tracing, because the galaxies we are moving toward, the structures we have been following, the destinations that seem so distant, will not remain fixed. They too will drift. They too will be carried away, and in that gentle, relentless expansion, we begin to approach one of the most profound truths of all, that the journey we thought we were on may never reach its end. If you follow that quiet shift all the way through, letting the idea of accelerating expansion settle gently into place, something begins to feel different. At first, the story of motion felt like a journey, a slow drift towards something, galaxies flowing along invisible pathways, clusters gathering, structures forming. It felt as though everything was, in its own quiet way, heading somewhere. But now, that sense begins to soften, because once expansion takes over, once space itself begins to stretch faster and faster, the nature of the journey changes, not abruptly, not dramatically, but inevitably. To understand this, imagine walking toward a distant mountain. It sits on the horizon, steady and unmoving. You take a step forward, and it feels closer. Another step, closer still. The path is long, but the destination feels real, reachable. Now imagine something subtle begins to happen. With each step you take, the ground beneath you stretches ever so slightly. Not enough to notice at first, but enough that the distance between you and the mountain stops shrinking as quickly as it should. You continue walking, you continue moving forward, but the mountain is no longer getting closer in the same way, and then, slowly, something changes. The stretching becomes just a little stronger. Now, even as you walk forward, the distance stays the same. You are moving, but not approaching. And then, one step further, the stretching becomes stronger still. Now, despite your effort, the mountain begins to drift away. You walk forward, and it recedes. You continue, and it retreats further. Not because you have stopped moving, but because the space between you and your destination is expanding faster than you can cross it. This is, in a very soft and simplified way, what is happening in the universe. The galaxies we once imagined moving toward, the regions we traced through the cosmic web, they're still there, still following their paths, still participating in the slow currents shaped by gravity. But the space between us and them is changing, it is stretching, and that stretching is accelerating, which means that beyond a certain scale, beyond a certain distance, no matter how long we wait, no matter how far the motion continues, the destination will never be reached. The journey will never complete. Now it is important to hold onto something gentle here. This does not affect everything. On smaller scales, gravity still holds its quiet power. The Milky Way and the Andromeda Galaxy, for example, are already bound together by their mutual pull. They are close enough, connected enough, that expansion cannot separate them. Over billions of years they will drift closer, interact, and eventually merge into a single, larger galaxy. A slow, graceful union. And within galaxy clusters, similar things happen. Galaxies orbit one another. They collide, merge, and reshape themselves. These local journeys still unfold, They still reach their conclusions, but beyond those scales, beyond the regions where gravity has already established its hold, the story changes. Structures that are not already bound together will never become bound. The expansion of space will outpace the pull of gravity, and so galaxies that might have once drifted toward each other will instead drift apart, their paths stretching, lengthening, until the connection between them is lost. And this leads to a quiet but powerful realization. When we look toward regions like the Great Attractor, when we imagine the long, slow flow of galaxies moving in that direction, it feels like a journey with an endpoint, a convergence, a gathering. But in reality, that journey will never be completed, because even as we move toward that region, it too is moving. It too is being carried by the expansion of space, and the distance between us and it is not fixed. It is growing, slowly at first, then faster and faster still, until eventually the separation becomes insurmountable, not in a dramatic sense, not in a way we would notice within a human lifetime, but over cosmic timescales, it becomes absolute. And so, we arrive at a strange and beautiful truth. Everything is moving. The Earth spins, the Sun drifts, the galaxy flows along the cosmic web. Superclusters trace vast, slow currents through space. All of it in motion, all of it following paths shaped by gravity and structure. And yet, on the larger scales, there is no final arrival, no ultimate destination where everything comes together, because the universe itself is expanding in such a way that distant regions are carried beyond reach, and so motion continues, but completion does not. It is a journey without an ending, a path that stretches indefinitely, a movement that never quite resolves. And there is something quietly profound in that, because it changes how we think about direction, about purpose, about the idea of going somewhere. In the universe, motion is not always about arrival. Sometimes it is simply about movement itself, about the unfolding of paths, even if those paths never meet, about the quiet continuation of motion across time and space without a final point of rest. And as we move forward, this idea will deepen even further, because if distant galaxies will never be reached, then over time, they will also disappear, not physically vanish, but fade from view, carried so far away by the expansion of space that their light can no longer reach us. And in that fading, in that quiet disappearance, we begin to approach the final phase of this story, a future where the universe becomes darker, more isolated, more still, where motion continues, but with fewer and fewer things left to move toward. And in that distant future, the question we began with will take on a very different meaning, because when there is nothing left to compare against, nothing left to approach, nothing left to reach, what does it mean to be moving at all? If you let that thought settle, that quiet realization that some journeys will never be completed, something even softer begins to unfold, because it is not only that distant galaxies will remain out of reach, it is that, over time, they will begin to disappear, not in a sudden way, not like a light switching off, but gradually, gently, almost imperceptibly at first. To understand this, imagine looking out across a vast landscape at dusk. In the distance, you can see hills, trees, small details scattered across the horizon. As the light fades, those distant features begin to soften. Their outlines blur, their colours fade, and eventually they slip beyond visibility. Not because they have ceased to exist, but because the light carrying their image no longer reaches you. something similar is happening in the universe, but instead of fading light, it is expanding space that changes what we can see, because as space stretches, it also stretches the light travelling through it. The waves of light become longer, more spread out, more gentle, and as they stretch, their energy decreases. They shift beyond the range that our instruments can easily detect, and at the same time, the sources of that light, the galaxies themselves, are being carried farther away, more distant, more separated. So now there are two quiet effects working together. The light is weakening, and the distance is increasing, and beyond a certain point, those galaxies become unreachable in a very literal sense. Their light, no matter how long it travels, will never reach us, because the space between us and them is expanding too quickly. This boundary, this limit of what we can ever observe, is known as the cosmic horizon. And if we soften that idea, it is like a horizon, not a physical edge, not a wall, but a boundary defined by what light can cross, a gentle line beyond which information can no longer travel back to us. And as time goes on, that horizon changes. It does not expand outward to include more of the universe. Instead, it effectively shrinks in terms of what remains visible, because more and more galaxies are carried beyond it. More and more regions drift into a state where their light can no longer reach us, and so, slowly, the visible universe becomes smaller, not in size, but in content, in richness, in connection. Now, this does not happen quickly. On human timescales, the night sky appears stable, the same stars, the same galaxies, the same quiet patterns, but over billions of years, the change becomes undeniable. Galaxies that are now visible will gradually redshift, their light stretching into longer and longer wavelengths. They will become dimmer, fainter, harder to detect, and eventually invisible, carried beyond the horizon of what we can observe, until one day, far in the future, an observer looking out from our region of space would see something very different from what we see today. They would not see a universe filled with galaxies. They would not see the vast cosmic web stretching across space. They would see only a small, isolated region, a single gravitationally bound system, the result of the merger of the Milky Way, Andromeda, and a handful of nearby galaxies, a lone island in an otherwise empty sea. Everything else, gone from view, not destroyed, not erased, but simply too far away, too disconnected to be seen. And this creates a profound shift in perspective, because the universe, which once appeared vast and richly structured, becomes quiet, sparse, isolated. The grand flows we have been tracing, the currents of galaxies moving along filaments, the pull of distant structures, all of it fades, not because motion stops, but because the connections between regions are lost, and in that future, even the evidence of the universe's expansion becomes difficult to detect, because without distant galaxies, without the light from faraway regions, there is nothing to compare against, nothing to reveal the stretching of space, and so an observer living in that distant time might look out at their surroundings and conclude that the universe is static, that it consists only of their local system, that there is nothing beyond. The vast history we have uncovered, the expansion, the cosmic web, the flows toward distant structures, would be hidden, not because it never happened, but because its evidence has drifted away. And there is something quietly humbling in that thought, that our current view of the universe, this rich, detailed picture of galaxies and structure and motion, is only possible because we exist at a particular moment in time, a moment when the universe is still connected enough, still compact enough, for light from distant regions to reach us. We are, in a sense, living in a time when the universe can still be seen, when its story is still visible, when its motion can still be traced, and as time continues, that window will close, slowly, gently, without drama, just the quiet expansion of space, carrying more and more of the universe beyond our reach, until what remains is only what is closest, what is bound, what cannot be pulled apart, and so the story of motion reaches a new stage, not one of convergence, not one of gathering, but one of separation, of fading, of quiet isolation, and yet, even in that isolation, motion does not stop. Galaxies continue to move, stars continue to orbit, time continues to pass, but the scale of motion, the context that gives it meaning, begins to disappear. And as we move into the final part of our journey, we begin to ask a deeper question. Because if motion depends on comparison, if it requires reference, if it needs something to move toward or away from, then what happens? When those references are gone, when there is nothing left to compare against, nothing left to approach, nothing left to see, what does motion become in a universe that has faded into quiet isolation? If you remain in that quiet future for just a little longer, where distant galaxies have faded, where the sky has grown sparse and still, something deeper begins to emerge. Because even though motion continues and something essential has changed, not the movement itself, but the meaning of that movement, right now, when you think about motion, it is always tied to something. You move relative to the ground. The Earth moves relative to the sun moves relative to the galaxy moves relative to the faint glow of the universe itself. There's always a reference, always something to compare against, and because of that, motion feels real, meaningful, defined. But in that distant future, the situation is different. Imagine looking out into the sky and seeing only your local system, a single galaxy, formed from the merger of many, stars drifting within it, orbiting slowly, quietly, in a stable bound structure. Beyond it, nothing. No distant galaxies, no clusters, no cosmic web, no faint patterns stretching across the darkness, just empty space. Now imagine trying to describe motion in that environment. You could still say that stars are orbiting, that objects are moving within the galaxy, that time is passing, that positions are changing, but something is missing. There is no larger frame, no external reference, nothing beyond the system to compare against, and without that comparison, motion begins to lose its context. It becomes internal, self-contained, difficult to interpret. To understand this more gently, imagine sitting inside a perfectly sealed room. No windows, no sound, no external cues. If the room begins to move at a constant speed, you would not feel it. There would be no way to tell, no way to say whether you're moving or at rest, because motion without change, without comparison, becomes indistinguishable from stillness. And this is what the distant universe begins to resemble, a vast, isolated system, moving within itself, but with no external reference to give that motion meaning. Stars orbit their galactic center. Clouds of gas drift. Black holes slowly merge. All of it unfolding according to the quiet rules of gravity. But there is no larger backdrop, no cosmic web to trace, no distant structures to reveal direction, no ancient light to serve as a reference. Even the faint glow we once used, the background radiation from the early universe, will have stretched so much, cooled so completely, that it becomes almost impossible to detect. Its wavelength, once measurable, will have grown longer and longer, until it fades into the quiet background of space, still there, but no longer accessible, no longer useful as a guide, and so the universe becomes self-contained, closed in a practical sense, not because it has boundaries, but because everything beyond a certain distance is forever out of reach. And in that state, the concept of motion becomes something different. It still exists, but it no longer points outward. It no longer connects regions. It no longer leads anywhere beyond the local system. It becomes circular, internal, like the ticking of a clock in an empty room. Time passes, motion continues, but there is no larger story unfolding beyond it. And this brings us to a quiet, almost philosophical place, because from our current perspective, motion feels like a journey, a path from one place to another, a movement through a larger structure. But in that distant future, motion is no longer about travelling across the universe. It is about the internal evolution of a single isolated system. The larger connections have faded, the grand flows have dissolved, the cosmic context has slipped away, and what remains is local, contained, quiet. Now, there is something both humbling and strangely comforting in this realization, because it reminds us that the meaning we assign to motion depends on what we can see, on what we can compare against, on the structures and connections that are visible to us. Right now, we live in a time when the universe is still richly connected, when we can observe distant galaxies, when we can trace the cosmic web, when we can measure motion across vast scales. We can ask where everything is going and find meaningful answers. But that is not a permanent condition. It is a moment, a window, a brief period in the long history of the universe, where its structure is still visible, where its motion is still traceable, and because of that, we are able to understand something that future observers may never know. That the universe was once connected, that galaxies once filled the sky, that motion once had direction, and scale, and meaning beyond the local. And so, as we come to the end of this quiet journey, the question we began with, where is everything in the universe going, finds its answer, not in a single destination, not in a final gathering point, but in a process, a flow, a gradual unfolding. At first, motion gathers, structures form, galaxies drift toward one another. Then, motion stretches, expansion takes over, distances grow, connections weaken, and finally, motion remains. But meaning fades, because without reference, without comparison, without a larger context, motion becomes indistinguishable from stillness. And so, everything continues to move, quietly, endlessly. But in a universe that grows ever more isolated, that motion no longer leads anywhere. It simply is. And in that stillness within motion, the story of the universe comes to rest.